This case study will discuss the 2013 FAA decision to ground the Boeing 787 Dreamliner fleet, the safety issues that the model faced, the contributing factors that led to said issues, and the lessons and benefits that resulted. So to start off, we'll cover a quick chain of events that led to the grounding of the fleet. December 4th, 2012, a United Airlines 787 made an emergency landing due to a power generator failure. 9 days later, Qatar Airways grounded one of their own for the same issue. 4 days later, United Airlines confirmed another case of generator and electrical issues. On January 7th of 2013, a Japan Airlines 787 emitted smoke out of the aft electrical equipment bay due to auxiliary power unit lithium-ion batteries on fire. The next day, another 787 canceled takeoff due to a fuel leak. 8 days later, another had to make an emergency landing due to a battery malfunction warning. Following these events, the FAA grounded the entire fleet, which consisted of 50 jets worldwide, for 14 weeks and 2 days. Now, it was estimated to cost around $465,000 to repair each plane, and Business Insider estimated the total cost to Boeing over the entire period to be around $600 million. Japanese Airlines, ANA, and Japan Airlines estimated a combined $110 million in lost profits, and United Airlines estimated about $11 million. Now for a quick look at the history of Boeing, which was founded in Seattle by William Edward Boeing in 1916. Boeing began its growth via mail delivery commercial planes, aircraft manufacturing, and airline flights. During World War II, Boeing produced military aircraft technology for the U.S. During the 60s and 70s, they began pushing military helicopters, missiles, and both air and land craft for NASA. Now for the history of PDM within Boeing. As visualization and technology advanced, the need to manage the increasingly complex data grew. Some companies attempted to create their own CAD and PDM systems. In 1980, Boeing started to develop their own Tiger 3D CAD software, which was eventually scrapped in favor of partnering with CATIA in 1988. During the 90s, CAD programs had all shared very similar features. The push for new innovations shifted toward PDM, which had been successfully used in Boeing's 777 paperless design with Innovia. Boeing's incorporated Siemens PLM in 2006. As of 2018, both Dassault and Siemens platforms are used on the commercial side. Teamcenter and Windchill are big on the military side. It's a very complex PLM landscape that Boeing is looking forward to simplifying by working to consolidate into just using Dassault Systems' 3D experience, ideally. Now back to the Dreamliner. The model faced the following core problems. Fuel leaks due to incorrectly assembled fuel line couplings traced back to a manufacturing process at Boeing's South Carolina plant. Then there were electrical power distribution issues due to a software overflow of the generator control unit. And lastly, onboard fires due to lithium-ion batteries entering thermal runaway. Contributing factors include management decisions to outsource engineering and manufacturing work, as well as collaborate with over 50 different suppliers across the world, creating a poorly integrated supply chain. When dealing with so many suppliers, you have to work across a variety of organizational boundaries, and with a puzzle as large as building a plane, every contributor needs to know how their part fits. When unanticipated problems and changes arise, you must cross corporate boundaries, which could negatively affect a supplier's profits. A required change from one supplier may also force a separate supplier to change a component's design, which all snowballs and creates miscommunications between Boeing and the suppliers, poisoning the supply chain, increasing costs, and extending the production period for the Dreamliner, which is why the model was delayed 3 years and was billions over budget. Now, Jim McNerney, Boeing's chief executive at the time, stated he would, quote, draw the lines in a different place to ensure that come next time, outsourcing would not create such a disconnected supply chain. As for the FAA, they had been planning to revise their Modernization Reform Act of 2012 around this time, which seeks to improve aviation safety and capacity of the national airspace system. Revisions were influenced by lessons learned from the Dreamliner. To put it simply, this case study benefited the public in the aerospace industry by helping to improve the safety and testing standards to which future commercial aircraft would be held to, and it showed the industry the importance of a thoroughly integrated supply chain, proper communication throughout it, and the failures that can arise in its absence.
The Boeing 787's cutting-edge design goals, featuring an all-composite construction and electronically actuated controls, meant an extensive amount of new designs and product data would have to be created. Naturally, this would result in a larger burden for the management of product data. Previously, the decision to outsource engineering work to over 50 global suppliers was discussed. With outsourcing comes the natural barriers of time zones, languages, and customs. When it comes to managing newly generated product data between so many companies, even more problems arise. Overmodulation of critical systems early in their design process resulted in many issues, especially with regards to product data. One key issue was that Boeing did not supply original designs of all of the system's components to their contractors. Instead, they paid them to create original designs and models off of their specifications. With no centralized data system to provide a clear data authority, and independent contractors that did not necessarily communicate their data effectively, many assemblies for the 787 were incompatible upon assembly. Had Boeing provided original blueprints or been in full control over the distribution of their contractors' product data through more robust product lifecycle management, these incompatibilities may not have occurred. With each subcontract Boeing hired to create an original design, a new digital thread or data flow was created. For previous aircraft designs, Boeing had kept much of the core production responsibilities in-house and subcontracted lesser system components. The resulting network of independent companies, with their own concerns for IP and inexperience with global integration, meant that data flows between the contractors were poor or non-existent. Faced with a network of reluctant data flows, Boeing had considerable trouble managing the environment of digital threads. Careful introduction of new technology is important. New technology, as demonstrated by the lithium-ion batteries, should require new regulations, testing procedures, and safety standards. The testing method used on the lithium-ion batteries did not accurately represent the real-world failure. Execution of PLM on a global scale is challenging. It becomes exceptionally harder when it must integrate a network of global suppliers that not only produce their parts, but design them individually. The consequences of improper PLM can cause remarkable delays in production, an increase in cost of production, and it opens up the manufacturer to liability. Production delays were a key issue with the 787. With the planned delivery date of May of 2008 and the realized delivery date of October of 2011, the 787 had missed its mark by over 3 years. Costs were directly affected when suppliers were unable to meet their production deadlines. The most direct solution for Boeing was the buyout of certain underperforming suppliers, as with Global Aeronautica. Restitution fees were also necessary for affected suppliers, such as Vought. In regard to liability, the responsibility to fix issues with the batteries and fuel companies ultimately fell on Boeing. In addition, Boeing received substantial criticism from suppliers, citing that it was Boeing's responsibility to manage their Tier 1 suppliers, and the consequences of other suppliers causing delays should not fall on them. This case study showed that Boeing, an experienced aircraft manufacturer with a storied history of successful designs, had a remarkable number of issues during the production of the 787 Dreamliner. Many complications arose when a strategy revolving around a network of global suppliers was employed. Boeing's poor PLM resulted in critical issues within the digital thread and an inconsistent data authority, which is key for a model-based enterprise strategy. The consequences of this were apparent in the resulting budget overrun, as well as the battery, fuel, and software issues that grounded so many 787s.